Hello everyone, I'm Nishit Bagaita, and if you don't know me, you can just read my introduction. I'm an engineer who is a math teacher. Now we are just going to do a quick revision. So let's start with the triangle. The right angle triangle ABC is there, and what are the various combinations if you want to take ratios of two sides? So it can be AB over AC. You can flip them and it becomes AC over AB. Again, you have BC over AC, and you can flip them and get AC over BC. We have AB over BC, and we can flip them and we get BC over AB. So these six combinations are nothing but all six trigonometric ratios. These ratios are in the form of trigonometric functions. So in order to memorize them, you can just remember one thing called SOHCAHTOA. The six trigonometric ratios are called sine, cosine, tangent, cotangent, secant, and cosecant. In order to memorize them, that which function is for which sides, you have to remember one of the reference angles. For this example, we are taking angle C as reference. So I have marked theta over here. So what will be the opposite side to angle C? That will be side AB. And which will be the adjacent side? It will be side BC, considering AC as the hypotenuse. So what we have is, we have opposite side as AB, we have adjacent side as BC, and we have hypotenuse as AC when we are taking reference as C. If someone is taking A as reference, angle A as reference, in that case their opposite side will be BC and their adjacent side will be AB. Hypotenuse will remain the same. So AB over AC, what is that? Actually opposite over hypotenuse, that's what it says here. So is sine, S is for sine, OH is O over H. So opposite over hypotenuse is our sine theta. Same way, adjacent over hypotenuse is our cos theta, and opposite over adjacent is our tan theta. Again, there is a relation that if you flip these ratios, you get the other ones. So I have written in that way only, that if you have AB over AC, if you flip them, that means if you take reciprocal of it, it will become AC over AB. That will be our cos sec theta. Same way you get AC over BC as sec theta, and BC over AB is cot theta. You have to remember these six ratios, and from this six ratios you get a relation where sine theta times cosec theta, as they are reciprocal of each other. You learned this in lower grades, that if you multiply the reciprocals with each other, you get one identity element of multiplication. So from that you get a relation that sine theta is 1 over cosec theta and cosec theta is 1 over sine theta. Same way cos theta times sec theta is 1, which gives you cos theta equals to 1 over sec theta and sec theta equals to 1 over cos theta. Tan theta times cot theta is 1, because again tan and cot are reciprocal of each other. So tan theta will be 1 over cot theta and cot theta will be 1 over tan theta. If you look at this properly, if you take a ratio of AB over AC and BC over AC, AC will cancel out and you have AB over BC, which is nothing but our tan theta. Look, we have tan theta as AB over BC. So from that we have a relation that if you take a ratio of sine theta and cos theta, you will have tan theta. And if you just take reciprocal of it, so cos theta over sine theta will become cot theta. Now the list is big actually, but you can use various combinations. Like instead of sine theta, you can use 1 over cosec theta. Instead of cos theta, you can use 1 over sec theta. That's how your tan theta can become sec theta over cosec theta. Let's solve just one example. Here I have written that, let's say 4 cot theta is equal to 3. Then you have to find all the other ratios. So 4 cot theta equal to 3. Cot theta will be equal to 3 over 4, as 4 is in multiplication. Here it switches side, it will be in division. And if we just make an right angle triangle, Now remember, 3 over 4 is the ratio. It doesn't mean that the sides are 3 and 4. Sides can be any multiple of 3 and 4. So we have taken 3k and 4k. As it's cot theta, remember what's cot theta? Cot theta is adjacent over opposite. So if I have marked theta over here, this is my adjacent, which I have written it as 3k, and my opposite is 4k. So using Pythagoras theorem, hypotenuse square is equal to 4k square plus 3k square. After solving that, you will have hypotenuse as 5k. Again, you can just mark 5k over here, and you can find all the trigonometric ratios by just knowing that which are the ratios, like sin theta will be opposite over hypotenuse, cos theta will be adjacent over hypotenuse, and so on. So I have written them. Just pause the video and see. Okay, our next step is to memorize the values of certain trigonometric ratios at certain angles. Like if you look at your geometry box, you will have two set squares. One will be 30, 60, 90, and the other one will be 45, 45, 90. So these two triangles are marked in a way where you have one right angle triangle and these two are 45, 45, and here one is 30 and the other is 60. So if you are going to observe this triangle properly, look, if my side is x and this is x, you can use Pythagoras theorem and write x square plus x square equal to this hypotenuse square, and after that you will be able to find hypotenuse as x root 2. Again, coming to 30, 60, 90 triangle, here if the side is x and this is x root 3, then automatically the hypotenuse will become 2x. So how to use them? How to use these slides? How to use these sets? Like if you have a side opposite to 30 degree as, let's say, 5 centimeters, so automatically this will become 2 times x, which is 10 centimeter, and again this will become 5 root 3, right? Because it's x times root 3. Our x is 5 centimeter, so it will become 5 root 3 centimeter. In this case, let's say our x is 5 centimeter again. So again this side will become 5 centimeter and this side will become 5 root 2 centimeter. These are the things we have now. So in order to memorize all the angles and trigonometric ratios for those angles, you can either memorize just these two triangles, and if someone says that how much is tan 30, then you can use it. Let's take a few examples, like sine 45 degrees. So in that case, I am using this triangle. I am taking 45 as the reference angle, so my opposite will be x and my hypotenuse will be x root 2. So I took sine 45x as x over x root 2. I got rid of x and I just had 1 over root 2. You can just pause the video and take references of different angles and find different values. I'm explaining you one more example. Like here we have to find tan 60 degrees. So 60 degree is what? Actually x root 3 over x. So x will cancel out and we will have just root 3. Coming to the next slide. So if you are unable to remember those triangles, then we have an easy trick here. We just write all the possible angles which we need: 0, 30, 45, 60 and 90. We write all the numbers in sequence, like 0 over 4, 1 over 4, 2 over 4, 3 over 4 and 4 over 4. We'll take root of each of them and we will reduce the things. Like 0 over 4 is 0, so we know root of 0 is 0. 1 over 4, again root of 1 is 1 and root of 4 is 2. 2 over 4 is half, but if you take root it will be 1 over root 2. Root 3 over 2, because root of 4 is 2. And again here 4 over 4 is 1 and root of 1 is 1. That's how you get all the values of sine function for 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. Now if you want to find values of cos, you can just write these things upside down. Like this one will go here, root 3 over 2 will go here, 1 over root 2 will be here, 1 over 2 will be here and 0 will be here. Because if you remember, if you draw a triangle, let's say triangle ABC is there, then in that case, if you find this properly, look, for angle A, my opposite is BC and AB is my adjacent, but for angle C, my opposite is AB and adjacent is BC. So my sine of A will be what? BC over AC, and my cos of C will be again BC over AC, because for angle A, opposite is BC, but for angle C, my adjacent is BC. So that's the reason if you are finding sine of 30 degrees, that is actually your cos of 60 degrees. So that's how you can remember this. You write all the sine ratios, you just flip them and write it here. And then again, if you remember the relation, tan theta is sine theta over cos theta. So if you take 0 over 1, you will get 0. You will take half over root 3 over 2, 2 will cancel out and you will have 1 over root 3. 1 over root 2 over 1 over root 2 will give you 1. Root 3 over 2 over 1 by 2 will give you root 3. 1 over 0 is not defined, so tan 90 is not defined. Okay, now getting the values of cosec theta. If you remember the relation that 1 over sine theta is cosec theta. So if you take reciprocals of this, like 0's reciprocal is not defined, half's reciprocal is 2, and so on, you will get values of cosec theta. Again, to get values of sec theta, you can take reciprocals of cos theta, or you can just flip this cosec theta's chart. This 1 will go here, 2 over root 3 will go here, root 2 will remain here, 2 will come here, and this undefined will go last. Same thing works for cot, that tan and cot are even reciprocal of each other, and they also share the same property, that this tan of 0 degrees will be cot of 90 degrees. Tan of 30 degrees will be cot of 60 degrees. So either you can just flip this, like you can put this undefined in the starting and you can write root 3 here, 1 here, 1 over root 3 here, and 0 over here. Or you can also take inverses, like 0's inverse or reciprocal is undefined, 1 over root 3's reciprocal is just root 3, 1's reciprocal is 1, root 3's reciprocal is 1 over root 3, and undefined it was something over 0. So if you flip it, it will become 0. That's how you can remember this whole chart. Now how will these be useful to you? Let's have a look at one of the sample questions. In this question we have cot theta is root 3. So if you confirm the chart, look, cot theta is root 3 when angle is 30 degrees. So in this question, if you have cot theta as root 3, then theta will be 30 degrees. Remember, as of now in 10th grade, you are just studying these angles from 0 to 90. In future, you will be learning it from negative infinity to positive infinity. There the scenario will be different. So wherever these kind of questions are asked, where you are supposed to find just one value of theta, there will be a thing written that theta is an acute angle, or theta lies from 0 to 90 degree. So here you have theta as 30 degree. Now you have to find sine theta. So sine 30, again you look at the chart, sine 30 is how much? Half. Okay, so we are good with that. Sine theta will be half. Cos 30 will be root 3 over 2 if you look at the chart properly. Let's take one more example. Here the example says you have to find the value of 3 tan square 30 degree minus cot square 45 degree. So from the chart again you pick value of tan 30, that's 1 over root 3, and cot 45 degree will be 1. So you just plug in the values. Tan square of 30 means you have to square 1 over root 3, which is 1 over 3 times 3, and cot square of 1 is again 1. So you will have 3 times 1 over 3 minus 1, 3 cancels out, and you just have 1 minus 1, which will give you 0. Now comes a concept of complementary angles. You remember complementary angles are the angles if you add you get 90 degrees. In this triangle ABC, we have B as 90 degrees. So we will have A plus C will be equal to 90 degrees. So opposite for A will be adjacent for C, because look, opposite of A is this, but adjacent of C is again this. So opposite for A will be adjacent for C. Opposite for C will be adjacent for A. So if you are going to find the value of sine A will be what? BC over AC, because BC is its opposite side and AC is the hypotenuse. And same way, if you are going to find cos C, then adjacent over hypotenuse will be BC over AC. So you can write sine A equal to cos C. But you also know angle A plus angle C is 90 degrees. So instead of A, can I write 90 minus C? Yes, I can. So I will write sine of 90 minus C equals to cos C. That's from where I will pick this relation. It works for every trigonometric ratio. That sine of 90 minus theta will become your cos theta. Cos of 90 minus theta will become your sine theta. Sec of 90 minus theta will become your cosec theta. And cosec of 90 minus theta will become your sec theta. Tan of 90 minus theta will become your cot theta, whereas cot of 90 minus theta will become tan theta. You have to remember these relations because this will be useful to you in so many questions. Let's take a glimpse of that. Last question, we have sine 52 degrees times cos 52 degrees minus sine 38 degrees times cos 38 degrees. So here you can do two things. Either you can convert this sine 52 into cos 38 and convert this sine 38 into cos 52, so you will have the same things. Or you can convert sine 52 into cos 38 and cos 52 into sine 38. So that's what we have done right now, but you can use any other combination if you want. So here what I have done is sine 52 will be written as cos 38 by using the relation we just learned, and cos 52 will be written as sine 38. We are going to substitute it here. So you know cos 38 times sine 38 minus sine 38 times cos 38 is 0. If you want to explain more, you can just use commutative law of multiplication, that A times B is equals to B times A. So here cos 38 times sine 38, you keep it as it is, and sine 38 times cos 38, you just flip them. You can write it as cos 38 times sine 38. Now you have the same things subtracted from each other, so the answer will be 0. Let's have one more example. We have 10 of 10 degrees times 10 of 20 degrees times 10 of 30 times 10 of 60, 70 and 80. What we can do in this situation? If you convert all of them into cot theta, then it won't be useful. It will be a new question for us, right? So we are not going to convert all of them into cot theta, but what we can do is we can convert some of them into cot theta in a way that it will be useful to us. We know that one combination is there where tan theta times cot theta is 1. But in that also you need theta as same. You can't write tan of 50 degrees times cot of 40 degrees as 1. You have to write tan of 50 degrees times cot of 50 degrees 1. So here in this case what you can do is you can convert this tan of 60 degrees as cot of 90 minus 60, which will give you cot 30. Tan of 70 will give you cot of 20. And tan of 80 will give you cot of 10. Now you can just gather tan of 10 degrees and cot of 10 degrees together, tan of 20 degrees and cot of 20 degrees together, tan of 30 degrees and cot of 30 degrees together, and each of them will be 1 because tan theta times cot theta is equal to 1. That's how you will have 1 times 1 times 1, which will give you again 1. The last identities of this chapter, you can prove them by Pythagoras theorem and references, but right now we don't have a time as it's a revision lecture. We are just going to write them down. So we have sine squared theta plus cos squared theta equals to 1. The variation can be, you can just change the subject. You can just write sine squared theta equal to 1 minus cos squared theta. You can also write cos squared theta equal to 1 minus sine squared theta. Here you have sec squared theta equals to 1 plus tan squared theta. So you can again write tan squared theta equal to sec squared theta minus 1. And sec squared theta minus tan squared theta is equal to 1. Cosec squared theta equals to 1 plus cot squared theta. So if you make cot squared theta as the subject, it will be cosec square theta minus 1, and your cosec square theta minus cot square theta will become just 1. How we are going to use these things? Let me just give you a short example. In this question we have that express sec theta and cot theta in terms of sin theta. Means I want sec theta equal to something 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 sin theta, and I want cot theta as something of sin theta. Remember, here also one thing is mentioned, that theta is acute. If theta won't be acute, then in future you will learn that these trigonometric ratios can also have negative values. So here when you are taking x square as, let's say, remember that concept which you learned in previous years, that if your x square is 4, that doesn't mean your x is 2. Your x can be plus or minus 2. So this thing is there. So here, as theta is acute, we don't have to care about the negative sign. So sec theta will become 1 over cos theta. Again, you know cos theta is root of 1 minus sin square theta. That's how you can convert sec theta into sin theta. Again, cot theta is root of cosec square theta minus 1. Cosec theta is 1 over sin theta. So cosec square theta will be 1 over sin square theta. If you take LCM, here you have just 1. You have to make the denominator same. So that will become sin square theta over sin square theta. And you will just combine this thing. The denominator will become same. And you can just write 1 minus sin square theta over sin square theta. Now you know root of this thing is not possible. You write it like this. And sin theta is written like this. You can also convert the same question into another version. You can use cot theta as cos theta over sin theta. And you know cos theta is what? Actually root of 1 minus sin square theta. Because cos square theta equal to 1 minus sin square theta. And sin theta will remain as it is. That's how you can have this question easily. So there are multiple ways of solving a question, but yes, it's on you. Whichever you find it simple and easy, you can go for that. Okay, so if you have any doubts, you can just mention it in the comment section, and we'll come up with a new video of a new chapter in quick revision. Thank you everyone.